All right, so we're going to look at just triangles now for similarity. And as I mentioned, it's too much work to do the angles and the sides and all this other gunk, so we're going to come up with some shortcuts, which is going to go something like this. If my clicker would work, which is not going to come up here. All right, so here we go. Okay, nothing's working. There we go. We're going to start with a problem here. So here's you hauling around a wagon of math books. And here's a flagpole. Just to ignore the people running up the flagpole. The only decent flagpole I could find. Okay. You are 5'6", and your shadow is 6'6". Now, converting from English units to decimal or metric units or whatever, remember that 5'6" is not 5.6 feet. That's an incredibly common mistake. People take 5 feet 8 inches and say, well, that's 5.8 feet. No. It's not. 5'6" is 5.5 feet. Good. Okay, so there's a scenario. You're walking along, you see this idiot running up a flagpole. You know how tall you are, and for some weird reason, you know how long your shadow is. And you have a wagon full of books.
Math books.
Math books, correct. You also happen to know that the flag pole casts a 125-foot shadow. The question is, how tall is the flagpole? Go ahead, give it a shot. When you get your answer calculated, ask yourself a simple question. Does my answer make sense? Should the flagpole be taller or shorter than 125 feet? Shorter. Why?
Because it's like, if you look at like, never mind. Well, if you look at like the 5'6" and 6'7", this is 6'6". 6'6" is longer than the shadow.
Good. The shadow is, your shadow is longer than you are tall, so therefore the flagpole has to, or the flagpole shadow has to be longer than it is tall. So that's the first check. You should get an answer less than 125. Then make sure you get a reasonable answer. If you come up with something like 2 feet, you probably did something wrong. Okay, we got answers? Oops, sorry. My bad. Ben, what do you got?
105.8.
How do we feel about 105.8?
Good.
Yes.
Well done. Explain it.
Alright, so I'll start with proportion.
Hold on. I'm ready. Go.
Put 5.5 over 6.5 equals x over 125.
Well done. Everybody set it up the same way? Okay, you could have flipped it over. Could have done shadow over shadow equals height over height, then flip that. You can do it a whole bunch of different ways. Then cross multiply and solve. Ben,
Yeah.
that's based on one single assumption, and that is that the triangles are similar.
Yeah.
Are they?
No idea.
All right. I'll ask the rest of you. Are they?
Maybe.
Maybe. That's a good, safe, wimpy answer.
Unless there's more
Sometimes.
than one sun, yeah.
Unless there's more than one sun?
Yeah.
Well,
Uh,
he's a son.
As in like.
They're sons.
No.
That's a
As in,
daughter.
like, the sun in the sky.
With spelled with a U.
I misunderstood. I'm sorry. What do you mean by that?
Well, like the light source is coming from the same place, so they must be the same.
What's they?
Or the must be proportional. Or
Again, what's they?
similar. The two triangles.
Is everybody comfortable with that jump? There's one sun, so the triangles are similar.
No.
We're gonna need a little bit more clarification.
Yeah.
It's alright.
Sherpa?
What I just did was, even though like we still solved for it without knowing if it was a similar triangle, I divided 5.5 divided by 6.5, and then 105.8 divided by 125, and it was the same.
Excellent, but you just dodged the question though. How do we know the triangles are similar? What assumptions can you make about this picture? Hmm?
They're both triangles.
Good, they are both triangles. It's a good start. Emily?
I think they're right angles, maybe.
We can pretty much assume that no one put up a flagpole that wasn't perpendicular, and we can also assume that you don't lean. If you have one leg shorter than the other, then this whole problem falls apart. What else can we assume? What does his bit about the sun tell us? Are you raising your hand, Paul, or are you just waving your fingers around?
It's like a top angle or congruent to each other. I mean,
Top angles?
yeah,
So you're saying that this angle is equal to this angle
yeah,
because of the location of the sun?
yeah.
Good. Which would then, by the no choice or third angle theorem, would make that angle congruent to that angle. But that doesn't do it for us. Because we need to show not only that the three pairs of angles are congruent, which we've done, but we need to show that the sides are proportional. And we don't have enough information to do that. So we made kind of a big leap of faith here, and that leap of faith was that the triangles are in fact congruent. Were you going to say something, Evan?
No.
Okay. So what we actually used here is our first theorem, which is called the angle-angle similarity theorem. It was originally called, way back when I first started, it was originally called the angle-angle-angle similarity theorem. But then somebody came up with the idea that, well, if two of the angles are congruent, then the third angle has to be congruent by the third angle theorem, so therefore we don't need the third angle, so let's just call it the angle-angle similarity theorem. You must have that tilde after it. Without that tilde, it implies that it's the angle-angle congruency theorem. And what do we know about the angle-angle theorem? It doesn't work for congruency. It doesn't prove triangles are congruent, it proves triangles are similar. So really all we needed to prove that the flagpole triangle and the wagon triangle were congruent is we just needed that right angle and one of the other angles. And one of those other angles we got from the business about the sun. Want to guess what other theorems we get? Nobody? Have it.
The side-side congruent here, similar here.
You just want to go with two sides on that?
Side-side-side,
Side, side, side,
similar here.
similar theorem. Well done. Oh wait, I thought I had the theorem there. Yeah, there it is. Okay. And notice in the angle-angle theorem, angle-angle similarity theorem, it said that the angles have to be congruent. In the side-side-side similarity theorem, it doesn't say that the sides have to be congruent, it says the sides are proportional. Which means that yesterday when we were proving the triangles, these triangles in particular, similar, we showed the angles were all congruent and we showed that the sides were proportional with that one big proportionality statement. This theorem says I just need one proportionality statement and the triangles are similar. Okay, we good? Side angle side. You got to prove two pairs of sides proportional and the included angle congruent. Two sides proportional. 12 is to 4 as 9 is to 3. They have the scale factor of 3 to 1. And the angles, the included angles, are congruent, both 67 degrees. So again, we come back to the very first day when we said proportionality. I think it was the second day actually. When we said proportionality means the angles are congruent and the sides are proportional. That carries on through all the stuff that we're doing. Good?
No.
Good?
No.
How about now?
No.
No. Now?
Yes.
Yes? No? Yes? No? No?
Yeah.
Yeah, good. Are the triangles similar? So we're actually going to do three things to solve this. To solve this problem. We're going to determine if the triangles are similar. We're then going to write a similarity statement, because that'll make a good reference when we're solving for NP. And in fact, let's do the similarity statement first. Let's pretend that the two triangles in the picture are similar and write a similarity statement. So pick one triangle and start with it. I'll do NMP. If this actually proves the way that I think it will, which triangle will NMP be similar to?
RMS.
RMS. Are we in agreement? Beautiful. Okay. Now I have to figure out which theorem I'm going to use. What do I know from the diagram? Go ahead.
The angle M is congruent to itself.
Beautiful. Angle M is congruent to itself. That's a good start. Put a little circle there, just a little fancy reflexive angle there. So that means I'm probably going to use either side angle side similarity or angle angle similarity. What else do we know? Do we know anything about the relationship of angle NPM and angle RSM? Are they congruent? You got a 50-50 chance, live on the edge.
The triangle is similar.
Yeah.
Oh, now you put the cart before the horse. In order to prove the triangles are similar, we need to prove the angles are congruent, but we can't prove the angles congruent unless we know the triangles are similar.
Maybe.
Yeah, you like that maybe, don't you? Yeah, good. Good. That'll help you on the ACT too. E, maybe. E, maybe. E, maybe. Billy leaves his house at 2 o'clock. He's traveling 42 miles an hour. He travels for 3 hours. How far is he at 4 o'clock? Maybe.
Yes.
All right. Well, we don't know anything about the angles. So now we need to set up a proportionality statement to see if we can compare the sides. And the reason this is important is because we're going to compare sides, not just numbers. So for instance, if I do 10 over what? 25. Why 25? Well, 10 is MN. MN is the first two. Therefore, it has to correspond to RM, which the entire length of RM is 25. Equals 12 over what? 30. 10 over 25? 2/5. 12 over 30? 2/5. Yeehaw! What is that? Question, sir?
Wouldn't angle P be congruent to angle S because of the statement that was made?
No, because we cheated. We made the statement if we knew the triangles were similar. We used the statement to prove it, but we didn't know that yet. So now I've shown enough to make this a valid statement. Now the question is, what theorem did I just use?
Side angle side. The something. And
Maybe.
symbol.
Side angle.
Maybe. No?
Should
Maybe theorem.
Side angle, side similarity. And these theorems have a similar theorem that goes along with CPCTC. It's not CPCTC, but it's something similar. Now that I know that this is true, I see, Emmett, give me a second. What else do you know about the picture? Oh,
The corresponding sides are, so NP and RP are proportional.
good. We'll come back to that in a second. What else do we know?
Angles are congruent.
Yeah, that angle is congruent to this angle, and this angle is congruent to that angle. What does it tell you, other than what Paul said about the proportionality, what does that tell you about NP and RS? Emily?
They're proportional,
And?
so they would be equal to 2 fifths.
And? So give me the proportion you would use to solve for NP.
X over 20 is equal to 2 over 5.
Well done. I think I did that right, didn't I?
Yeah.
Yeah, good. And one last thing, what else do you know about NP and RS? Morgan?
Wouldn't they be parallel?
Beautiful, they're parallel. Why, Morgan?
Because the angles are congruent,
What kind of angles are those?
corresponding.
Good. Okay. This will help you a lot. Because a common mistake that people make in these types of problems is exactly what some of you made. You wanted to set up 10 over 15 equals 12 over 18. Okay. This is not a triangle. This is a trapezoid. It's not similar to the big triangle. So start with this similarity statement, and that'll give you the correspondence that you need to solve for that triangle. So you get the 10 over 25 equals 12 over 30. Okey-doke. Beautiful. I believe we are done. Yeah. Day tree. All right, we good? So a little bit of homework over the weekend. On Monday when you come in, we will start by going over this homework, and then I'll have a little bitty quiz for you. And Monday, I've decided to get a little bit crazy here, and we're not going to have homework Monday. I'm sorry, I know some of you feel deprived. If you're going to be really upset, I can whip something up for you, but, you know, it is what it is.
That's like it's so funny.